Okay, so let's start. So convert each fraction into a percent. First of all, what do you need to convert each fraction to before you do a percent? You do a decimal. How do you do that? Well, you just plug this into the machine and see what decimal you get. 1 divided by 4 is how much? 0.25. Oh, sorry, it's a different color. But then, how do you make this a decimal? You multiply it by a. There you go. So it's 25%. So if someone tells you, give me 1/4 of what you have, well, they're asking for 25% of what you have. Okay, three. Whoops. Yes, exactly. Sorry. There, 3/4. Same exact idea. If you divide, you get 0.75, which means if you multiply by 100, you get 75%. Okay, so this question is shade 75% of the diagram. Hey, must, which means how many squares would you have to shade? How many squares would you have to shade to account for? Okay, so everyone, there are two ways to do this. Either you keep shading differently, or so randomly and checking, or immediately at the beginning, you can what? You can calculate right there how many to what? To what? All you do is what? How many full squares do we have? Sorry, not full. How many squares do we have? 8. So everyone, look, you need to get 75% out of 8. So everyone, go ahead, write this. Oh, yes. Go. Oh, go. Walk in whenever you want. So I want you to write 75% of 8 is nothing much, just 0.75 times 8. Every time you want some percentage out of a number, just multiply the decimal version of that percentage by the number itself. So what's 0.75 times 8? No surprise, you get 6. So 6 squares or 6 boxes. Yep. So shade 6 in any way. You can shade the first 6 if you like. You can shade on and off. Let's shade on and off. Here's 2, and here's 2. Basically, just leave 2 of them untouched. Done. That's it. All right. 6 boxes. No problem. Okay. Convert. Okay, this is going to be an interesting one. And it's going to make me see how many of you understand time. Okay. Everyone, 1 hour and 1/4 is how many minutes? Okay. Who has okay, pencils down, pencils down. Who has a way of like understanding what it means to do hours and fractions of hours? How many people have a way? Apparently you had a way because you at least guessed an answer. What's your way? Everyone listen up. Ty is going to tell us how he understands. Okay, there you go. So we know that 1 hour, everyone, 1 hour right there is how many? 1 hour is 60 minutes. So we know that at least this is what? This is, everyone, write 60 here. Just write 60. But then I also have what? 1/4 of an hour. 1/4 of an hour. So all you have to do now is what? Is multiply, look, 1/4. So this is the way I'm going to do it. Look, I'm going to make a bracket. 1/4. So 1 divided by 4 times what? Times 60. Does anyone know how long 1/4 of an hour is in minutes? Ooh, 15. Here's another way. How long is half an hour? 30 minutes. Well, 1/4 is what? 1/4 is half of a half. So 1/4 of an hour is half of 30 minutes, which is, look, 15 minutes. So go ahead. 60 plus 15. How much is 60 plus 15 in total? 75. So if someone says, I waited for you for an hour and 1/4 of an hour, they basically said, I've been waiting for you for 75 minutes. Okay, how about this? Do you want to remember how to switch from dollar sign to cent sign? You multiply by what? How many cents and a dollar? Done. That's it. Whenever you want to go from dollar amount to cents amount, you just multiply that dollar amount by 100. So everyone, I just want you to do this times 100. Who remembers what do you do to the decimal point when you multiply by 100? Do you hop once or twice? Hmm. You hop how many? You always hop, everyone. The number of decimal points you hop, look, is just how many zeros you have. How many zeros do I have in 100? So you have to hop once and twice. So that becomes just what? No, no. If you Yeah, if you hop once, it's 12 and a half. Exactly. $1.25 is 125 cents. If you want to give it in full penny. There we go. No, exactly. Technically, everyone, to Sarah's point, there's a decimal, but where? At the very what? At the end. But please don't show it. No need. Don't show it. It's there, but you don't need to show it. Okay. I want you to cross out estimate and write what? Measure. Measure. Which means I need to give you rulers. Go ahead. Let's hear a couple of numbers to see if people agree on the measurement. How long? Okay, so Sarah already beat us to the punch. And 3.1? 3, all right, 3.1. So 3.1. Because the first one was estimate, remember? The first one was estimate, and exactly, and the second was actually okay. Measure and compare it to your estimation. Well, guess what? We already did that. Everyone, cross B. Cross B. Always good when you cross things out. Okay, next. How long, everyone? How long is 2 meters and 50 centimeters in centimeters? Okay, let's go back to our 2-meter sticks. Here's one, everyone. Here's one full meter. Here's another full meter. Say again. Exactly, everyone. Everyone, listen. Forget the 50 centimeters. 2 meters itself. 2 meters is how many centimeters? 200, because there's 100 plus 100. And then you add how much on top of it? Exactly. So this is technically, yeah. So this is technically what? 200 plus 50, which is 250. You got it. I'm just going to write the calculation above and the final answer. Okay. Okay. How about 2 meters and 50 centimeters in meters and a half? Exactly. Everyone, if you want to make, everyone, if you want to make 2 meters and 50 centimeters out of these meter sticks, well, sorry, you're still short half a stick. You're still short half a meter stick. So this is equal to 2.5 meters. Okay. How about 5 on your ruler right there? How about 5 centimeters and 3 millimeters in millimeters? Sorry, in centimeters. How many, everyone? How many millimeters in a centimeter? 10. How many millimeters in centimeters? Just 10, which means 5 centimeters. 5.3. You got it. 5.3. No, we uh, we have 1 millimeters. Everyone, how many millimeters in 5 centimeters? No, 10 plus 10 plus 10 plus 10 plus 10. How many? 50 plus what? 3 extra. So go ahead, just write 50 plus 3, which will be 53. Done. That's it. 53 millimeters. Okay. This question is kind of like a rounding question. The HST on a $99 purchase is approximately, okay, why are they saying approximately? Because they want you to round the 99 to how much? Come on, 99 is very close to what? 100. So they want you to calculate as if the price was not 99, as if the price was 100. You know what? We don't need to approximate. Everyone, I want you to scratch the word approximate. We are going to actually calculate. Does anyone remember how? By the way, how much is the HST by default? 13. So everyone, so we need 13%. We need 13% of, no, see, 100 if we're approximating, but we have calculators, so might as well actually do the exact number of 99, which is equal to 0.13 times $99, which is almost what? 100, sorry, almost $13. It's gotta be 12 something. 12.80. Sorry, 12. Okay. Uh, we did this before, I think. 0.13 times 99. Yep, $12.87 in taxes. If you round it to 100, it would have given you $13. So you're only 13 cents off. That's it. Okay. So today, let's go back to the geometry stuff we've been doing. Okay. Yeah. So fill in the missing. What does dimensions mean, everyone? If your younger sibling asks you, I've been hearing dimensions on geometry shape. Uh, I guess. You know what? Yeah, I'm not sure exactly how the words relate. Dementia is when, Alzheimer, you start to fog your memory and forget things and forget people and faces. But dimensions, what's another word for dimension? What's it? What's if I add lengths, or what's another word for length? No, for length and width and all. Okay, well, hold on. Perimeter is the perimeter is the addition of all of them. We just call them sides. Dimensions, dimensions of a 3D object means the sides of this 3D object. So everyone, go ahead, find the missing side. Okay, come on. What do these dashes mean? Exactly. Which means here, we know for a fact that this one has to be as big as this one, which means this one has to be big as this one. So how long is the bottom side? Has got to be 8 in meters. Oh, there. Okay, thank you. What are dimensions? They are how long. They are how long the sides. They are the side. They are how long the sides of shapes are. Whether the shape is 1D. Sorry, there's no such thing as a 1D shape, by the way. Shapes are either two-dimensional, like they are areas, or three-dimensional, like they are volumes, like a box or a pyramid or something. Okay, so they are how long the sides of shapes are. Okay. How about this one? By the way, what shape is this exactly? Oh, sorry, not exactly. Sorry, my bad. Not quite. Yeah, I spoke too soon. Yes, it's a rectangle. Oh, even though, remember, on my screen, it looks squished to be a square, but it's not. As long as the measurement do not support it, it is not a square. So obviously, this is equal to that, which means this is also what? 5 meters. Okay. All right. How about this one? That's a what? That's a perfect square. It's all three all the way. Three all around. 3, 3, 3, 3, which means 3 meters, 3 meters, 3 meters. All right. Okay. So, okay. The side question. What is perimeter? What do you do whenever you want to calculate perimeter? Remember, we calculate perimeter a lot of so many objects. Add what? Exactly. So you can say, what is perimeter? It's the full distance around a shape. It's the full distance. So it's the full distance or length, but let's say distance around a shape. Around a shape. I believe we defined it differently in the first part of the unit when we said it's the outside length of the boundary. Hey, guess what? It's exactly the same meaning. Remember, I barely ask you communication questions anyway. But if I ever ask you a communication question and you still say something that has the same information as my own answer, you get full marks. Okay. So the distance around the outside of a figure, by the way, not just any figure, it has to be what, everyone? No, it has to be two-dimensional. By the way, everyone, there is no such thing as the perimeter of a 3D shape. There is no such thing as the perimeter of this, for example. Everyone, what shape is this, by the way? Come on. No, no, a rectangle. A face is a rectangle. One face is a rectangle. But what's the whole thing? No, not a cube. If it's a perfect square everywhere. No, what's this? It's a mascot. Like what? It's yeah. Trust me, I don't want fancy names. This is a box made up of how many faces? Six faces. Two here, two sides, and two top and bottom. My point is, there's no such thing as a length of a 3D shape. You can't just say, well, can't I just add the side length? No. In 3D shapes, we either calculate the volume, like the size, like how much air can fit in, or how much water, or how much sand, or how many masks can you put in, or the surface area. What was the surface? Yeah, rectangle prism. Prism, they love it in science courses. Ms. Dorwood talked a lot about prisms. Anything that's 3D could be called a prism. Well, you know what? Yeah, because a prism is like what? So basically, it was like a glass tent, right? It was like a glass tent. So here in 3D, everyone, in 3D, we either calculate the volume, or the surface area. Like if I want to paint the sides of it, like the whole thing. In 2D, we can talk about what? What's this word? Perimeter or area. Everyone, never call it surface area for a 2D shape because it's just how many surfaces? Everyone, a 2D shape. Everyone, look, eyes on me. Everyone, what is this? It's a 2D. Is it multiple surfaces or just one surface? It's one. I mean, we're not going to count both sides, just one surface. But how about this one? Is it three? It's 3D. How many surfaces is it? It's six. One, two, three, four, five, six. So always watch out. Never call a 2D, never call a 2D shape, or never say that a 2D shape has a surface area. It just has an area. Okay. So this one is perimeter. Go ahead, perimeter. Okay. What's the perimeter of each figure in number one? So the three figures we calculated the missing sides for. All you have to do is just what? Add. By the way, all of them are four-sided, so you just have to add four sides. Yeah, and you can do the addition any way you want as long as you do all four of them. Don't forget a side. 8 plus 8 plus what? 4 and 4. 8 plus 8 is 16. 4 and 4 is 8. That's what? 24 meters of fence that you need around the shape. Okay, how about the next one? 6. Sure. Or 6 plus 5. I can mix and match as long as you do all four of them. Not quite. No. Because 6 plus 5 is 11. And yet another 11 is actually 22.
Yeah, I got 22.
But the first one's 24.
No, I meant
Oh, so yes, absolutely. As long as you do not overcount two extra sides or undercount two missing sides. How about the other one? It's a square. So, but how many ways can you do that? Two ways. You can legit add them 4 times, or you're like, hold on, I have four sides, but they're all what? The same. So why add four things that are identical when you can just multiply them by 4? So you can just say what? Oh, 4. Again, I'm not gonna take marks off if you add. I'm just giving you a quicker way. 4 times 3m, which is 12 meters of fence. Perfect. Either way, you get the same answer. All right. Oh, you're right. It is 12. Okay. Is it? Circle the activities in the box that may require. Okay. So framing a picture. Do you need to know the perimeter? I guess so, because you need to know. Perfect. Okay. So put a check mark. Filling a swimming pool. Why not? Hold on. Hold on. Hold on. No, hold on. Do you still need to know the dimensions in anything you do? Dimensions, yes. How about the perimeter, which is the addition of all the dimensions? If I want to fill, everyone, what did we say about 3D shapes? Do 3D shapes ever have perimeter? So one way you could say filling a swimming pool, and by the way, a swimming pool is definitely what? 3D. I mean, you're not filling an area, you're filling a volume, right? So that means what? Filling a 3D shape does not make sense to talk about perimeter. Also, 3D shapes don't have perimeters. So filling a swimming pool does not need perimeter. It needs you to know about what? What do you call the inside of a 3D shape? Volume or size or capacity. Yeah, so yeah, filling a swimming pool? Nah, not quite. You still need to know how big it is, but not in a perimeter way, in a volume way. How about painting a room? But hold on. It's not asking do you need to know the dimensions. It's asking you do you need to know the perimeter. Uh-huh. Uh-huh. No. Hold on. This is a good discussion. Everyone, just so you know, knowing the dimensions of the wall, the dimensions, is not the same as knowing the perimeter of the wall. Knowing the perimeter means I need to know the dimensions, look at me, and then add them up. When you paint, do you paint the outside, like the boundary of the wall, or the exactly? You paint well. Oh, no, but I mean, do you paint like? Give me. I need a 2D thing. I'll use one of those boards. Everyone, if this is the wall and you want to paint it, are you gonna paint this? No, you're gonna paint this. So what am I painting? Perimeter or area? Exactly. When you paint, everyone, just so you know, when you paint, you never care about volume because you're not filling, and you never care about perimeter because you're not walking around. You're just painting the what? The inside of an area. So technically, painting a room, you you need to know the dimensions, but you don't need to work out the perimeter of it. So that's an X. Okay. How about fencing a garden? Just because that includes you walking around the garden. The fact that you're walking, yeah, exactly. Cutting the lawn, yeah. But do you need the perimeter of the like? Let's say I'm cutting this much. No, because technically I'm not cutting along the sides. I'm cutting the what? The inside of the area. So I kind of need to know how big my yard is, not how long my fence around my yard is. So technically, no. I need area. I'm dreading when I have to do it now, like in the next couple of weeks. How about installing a baseboard trim? What's a baseboard trim? Those ones. Exactly. I guess we are what? But but that means we're what? We are what? We're walking around. So that means I need to know the perimeter. Yeah. How about carpeting a room? Hold on. Do you carpet the side of the room or the inside of the room? You carpet the floor. And the floor is like painting or what? Painting a board, which means you need the area. I don't need the perimeter. I need the dimension, but I don't need the perimeter. Okay, how about wallpapering a room? Mm, really? Hold on. Wallpapering means what? You're putting wallpaper on the what? But on the what? On the wall, which means you're not caring about the addition of the perimeter. You're caring about the what? What's this? What's this? No, no. Area. This is area. And when you put your wallpaper, yeah, you need to know how big your room is, but that doesn't mean you need to know how big the addition of the wall distances are. You just need to know the area of the wall. So technically, no. Huh. All right. So three things really directly have to do with what? With a perimeter, which is walking around the picture, walking around the garden, and walking around the baseboard trim. So you said? And five things don't. Although one of them only had to do with volume. Which one of these had to do with volume? The pool, because it's 3D, and all the other ones had to do with 2D, which is what do you call this? What do you call this? Area. Thank you. So everyone, if you everyone look, how about this? Check this out. Put V here. What does V mean? Volume. Put A here. What does A stand for? Area. Put A here. Area. Put A here. Put A here. So when you read this again, you're like, oh, okay, we don't need the perimeter, but I wonder what else do we need? Well, you need volume for one and area for four others. All right, nice. Let me just finish this one, and then we can go. Okay. See, you are a generation that should know how to research things. Yes. So list 3 occupations that might require a working knowledge of perimeter. Fencing. Okay. So I guess fencing was right there in one of the ones in the previous question. I guess we can survey, but I guess we can say framing. I love it. My dad owns it. Yeah. Why? Oh, we already have fence. Yeah. You do? Okay.
I think that royal fence
Royal fences. Is that good? All right. What? So fencing. Can we say framing? I mean, well, technically, they did use the word framing in here. Obviously, I'm not talking about framing a picture. I'm talking about framing a house, or not framing a house, framing the windows on a house. So I guess framing. And Sarah got the surveying, which is correct because surveying is all about knowing distances between like buildings and stuff. So surveying. Although if you just said carpenting, technically, yeah, they cover. They don't cover volumes. Well, I guess yeah, they make volumes. I mean, you tell them how big a room is, so you technically tell them how big the space of the room should be, both area and volume. Surveying. Okay, next one. All right. Measure and record the length and width of each item listed in the table. Okay, since I want all of us to have the same answers, I'll measure those, and you will just what? You will just copy the same answer, so we don't all have different answers. So, teacher's desktop. Length. All right, well, I guess this could be enough for it. Okay, everyone. Length. Just give me a second. We'll do everything in centimeters. We'll do everything in centimeters. So, I'm going to go that a teacher's, this desk right here, is about. Okay, everyone, I am getting one. Oops. Everyone, I'm getting 100. By the way, put it in centimeters, centimeters, centimeters. I mean, we could have done it in absolutely any other unit, but let's go in. Okay. 115 centimeters. For what? For the length of a teacher's. Yes. And it should, by the way, do you know how, everyone, do you know how big this the paper usually uses? In inches. Does anyone know? Yeah. Come on. If you ever buy, like if you ever buy this. Yeah. But what's usually the paper size that we feed into printers? Does anyone know? Now the legal size. The legal size is long. No, in inches. It's always if you go home right now and you choose the printer size, oftentimes you're gonna be given a few sizes. One of the most famous ones is 8.5 by 11. Yeah, 8.5 by 11. If you actually right now measure the side of the paper that you have in inches, no, in inches. Use this one. Oh, they're in the. Yes. So if you measure in inches, yeah, it should no this side like this. Oh, you know what? How about this? Choose. Take this one. Take this one. So everyone, look. If you measure this short side, it should be 8.5. So up to here is 6. Yep, 8.5. And this one has to be 11. So, okay, I want you. Can I just use your pencil? I just open the mark. Up to here is 6. So this has to be 5 inches. The rest of it. Yep. By the way, everyone, it's always measured by default. This size, I think it's called A4. A4 is always 8.5 by. If you obviously, what happens to a printer if you feed the wrong size of paper into it? Boom, jams, and you don't want that, especially when you're a teacher and you have something urgent to handle. So this 150 centimeters. Okay, now I need to do the other side, which is the short side of the desk. Everyone, the short side of the desk, I'll tell you what I'm getting. I'm getting 75. Go ahead, 75. So my question now is, what would be then the perimeter of the desk? Would I just add these two, or do I still need two more of them? Yes, because remember, a rectangle has how many lengths? No, how many lengths? Two. And how many widths? Totaling up to four sides. So it makes sense. So I need to double this guy and double this guy and then add them up. So I'm just going to do the whole thing for you right now. So everyone, 115 times 2 plus 75 times 2. Oh, sorry. It was 380. Everyone, if you want to border up that, if you want to border up this teacher's desk, you have got to use 308 centimeters of whatever material you need. Okay, duct tape. Display board. Yeah, I'm not sure. Display board. Do they mean the screen? Or maybe that display board? Hey, let's use that one. Okay, everyone, this display board. Oh, okay. To know what they mean, everyone, I just want you to sketch this. Like sketch this. Just hold on. Let me just finish the sketch. I want you to sketch. Yeah, I guess like this. So this will be the board, and then sketch an easel like this. There you go. That kind of looks like this. Come on. Just sketch that. Just basically a board with its own easel. That's whatever is written here. So, how long is the long side of the board? Okay, hold on a second. Well, not the easel, the board itself. Okay, everyone, I'm getting 90 centimeters. 90 centimeters is the length. Go ahead, 90. How wide is it? 60, 66. So what do I need to add? 90 plus 90 plus 66 plus 66. So 90 plus 90, I know it, it's 180. And 66 is, yeah, 132. There you go. That, everyone, look, this board right here has a perimeter around it of 312 centimeters. Okay, what's next? Sheet of paper. Okay, sheet of paper. You know what? Yeah, but we did it in inches. By the way, technically, can we use that? Yeah, we can. But have we done inches and feet measurements yet? No, we're still sticking to what, meters, millimeters. So I'll actually give it to you exactly right now. Everyone, I know the conversion. I'll teach it to you next week. I know the conversion between centimeters and inches. Do you remember what was the long edge of the paper? How long? 11. Everyone, 11 times. Okay, listen up. Does anyone know how many centimeters in an inch? How many centimeters is in an inch? Nope. Less. Okay, the closest one is it's actually 2.54. An inch, everyone, an inch, listen up, an inch is slightly over 2.5 centimeters. Just this much. So I'm gonna multiply 11 by 2.5, 2.54. There you go. If you measure the length of the page right now, it should give you 27 centimeters, almost 28. Almost 28. So I want you to write what? 28 centimeters. Okay, what was the width of that page? We said that the length is 11 inches. What was the width of any A4 type page? 8.5. So I'm going to multiply 8.5 by the magic number of 2.54. This number is very close to what? Very close. Uh, come on.
No.
At least if you say 21, it would be closer. It could be 22. Could we say 21 and a half? Yeah, I'm only what? Slightly, like a few millimeters off. So 21 and a half. Okay, what do I do? Same thing. You need two of these, and you need two of these. So I know that 28 times 2 is 56. 56, yes. So 56 plus, how much is double of 21 and a half? 43. So that paper, interesting. That paper is 99 centimeters all around. Not inside the area, all around the perimeter. What's a PA speaker? Yes. Well, I guess so. PA speaker. All right. Well, it looks like a what? Looks like a perfect what? Square. So I'm going to need the ruler. Okay. Everyone, in centimeters, it is it's about 31 centimeters. And I'm going to assume it's the same this way too. Let me check. Yep. 31 centimeters as a perfect square. So 31 centimeters and 31 centimeters, which means 31 plus 31 plus 31 plus 31, which means 31 times 4, or 120, 124 centimeters of length around. Okay? Sure. Okay, everyone, this one is interesting. Why? Because you're shown some length, but you're not shown the rest. And without measuring, because you can't guarantee that this is to scale or if it's even a good diagram, figure out the rest of the dimensions. Okay, everyone, let's look at this carefully and see. Okay, everyone, how long is this side? Come on. How long is this side? Okay, so we don't need it because we have it. How long is this side? 2. How long is this side? How long is this side? So how long are these two now? How long is this? And how long is this? Exactly. Everyone look. Pencils down. This thing right here, look. This thing right here is all of this minus this. So it's this one. Perfect. So 6 minus 3 is 3 meters. 7 minus 2 is done. That's it. Obviously, on a test, I'm not going to tell you this. I cannot tell you this part. Otherwise, basically, you're not doing anything. You're merely just doing a subtraction. You need to know what subtracts what. Okay? How about this one? This one right here is 4 minus 1. Everyone, look. Focus with me here. This thing right here, look. This thing right here, just eyes on the screen for a minute, is this thing minus this. Yes. So it's 4 meters minus 1 meter. So this right here. Okay. All right. How about this one? Well, this thing right here is going to be what? It's going to be all of this minus this part. So it's what? It's also 5. Sorry, it's this thing is 5 minus 1, which is how much? 4. Okay. Obviously, calculate the perimeter. Well, now that we know all the side lengths, we can just add them up. Okay. Can someone tell me what's the perimeter? Excuse me. What's the perimeter? What's the perimeter of this one? Of the top L shape? You just have to tell me. Make sure when you add, you do not skip a side, but also you do not overcount a side. So, okay. Okay, Lorcan, what side do you want to start from? 7. So 7, and then you can start to walk this way around it or this way. So let's say 7 plus what? Plus 5. Everyone, might as well. Since we have it, put 5 here. Go ahead. Put 5 here. And put also 3 here. Good. Now we can just go around and add up. So 7 plus 3 plus 5 plus 3 plus 2 plus 6. Do we have enough space? Like, is it written for us or no? Oh, okay. Let's write it down. So I need someone to help me remembering the numbers. So 7 plus, come on, 3, 5, 2, 6. No, we had 6 sides. There's another 3?
Yeah.
Okay, all right. I don't have it in front of me, so I don't. Okay, all right. So what's the addition of these? Well, 7 plus 3 is 10. Plus 5 is 11. Yes, I think you're right. 10 plus 5 is 17. Yes, 26. 26 what though? 26 meters, not meters squared, because we're doing just perimeter. Okay, how about the other shape? 18? Well, okay, what are the sides? Just to check. Well, let's start. 5 plus 1 plus a 4. Everyone, this is a 4. And there's another 4, and there's a 3, and there's a 1. So 5 plus 1 plus 4 plus 3 plus 1 plus 4. So 5 plus 1 plus 4 plus 3 plus 1 plus 4. And Lorcan said 18. Because, yes, it is 18. 18 what? 18 meters again. Nice. Okay. How do you find out now the missing side? Okay. Obviously, everyone, this one and this one, are they the same? They definitely look like it. So everyone go ahead. This is 1 meter. Okay. How about this one? How about this thing? No, this one. Just this. Exactly. They are identical and parallel. So it makes sense to say that this is as long as this one. And they say 4 here, so it must be 4 here. Go ahead. 4 meter here. How about this one? From here to here. It's the same as this one. So it's what? It's 3. Okay, hold on. By the way, I want to get your attention to something like here. How long is the whole thing here? Interesting. What's 3 plus 3 plus 1? Makes perfect sense. So it checks out that the top side covers everything at the bottom too. Okay, this one.
Oh, we missed the
Sorry, which one? Oh, draw an example of an irregular figure. Oh, irregular figure is basically what? Anything that is just based up means composite, made up of so many sides that none of them could qualify as a single basic shape like a square or rectangle. So here's an irregular figure. Answer whatever you want. Just make sure it has what? Sharp edges, like not round like this. Nope. I mean, I guess the easy shape is an L shape, but come on, we can do an I. Everyone go ahead, just like maybe this, and then an L like this. Yeah. Like let's say you watch football, you see those, like the logos for teams like Michigan State. They always have this, something like this, for example. Not sure exactly how it looks like. I think it's an M, so like this. How is the Michigan State? Yeah.
Yep. Messed up.
I ruined it, not just messed it up.
Yeah, you made it worse,
I know. How is it supposed to?
bro. That's awful.
Oh, I did it. I started right,
Yeah.
and then I ruined the
You're
crap out of it.
failing.
Michigan State. Logo. Ah, there we go. Yeah, definitely bad. Yeah. Is this a regular or irregular shape? Irregular. It's made up of so many, like, turns and sharp edges and stuff. All right. Next. Okay, here. Okay, how are we gonna do this one? Come on. I need help. The first one is 2. Hold on. Are you telling me that? Are you telling me this
They're not
is as
the
long as this?
same.
Yeah. By the way, even if it's not squished, even on your paper, it's
Still
not.
the same.
So
What's
how would
higher
I?
than the
Okay, at least this one, for sure. This one. That's a 3. Okay, at least we got that. Can someone tell me what to do to figure this one out? Thank you. You know that the whole thing is how long? Everyone, you know? Yep. Perfect. Everyone, look. We know the whole thing is how much? Oops, sorry. We know the whole thing is 7, like this. Everyone, this whole thing is 7. This one's how much? This one's how much? So whatever this is, here's a different color. Whatever this is, all of these have to add up to 7. So obviously, the calculation is what? 7 minus 2.5 minus 3. Yep. And 1.5 is the only one that if you add to 3 and 2.5, would give you 7 back. Perfect. Oh, don't forget 1.5 meters. 1.5 meters. This is the kind of geometry shapes that I used to struggle with. Oh, I used to struggle with this all the time because I couldn't for the life of me see what should subtract what. And it didn't help me obviously measuring them because all the shapes were given out of scale. Or sorry, not to scale. Yeah. Oh, did I print 4, 6, or oh, it's a 6. Okay, no, good, no problem. Okay, calculate the parameter of each figure in number 9. All right, let's add them up. So the first one is what? So how did we figure that out? Well, come on. Oh, oh. First one is what? 7 plus 1 plus 3 plus 4 plus 1 plus 4 plus 3 plus 1. Stop right there. Don't count again because then you'd be doubling up on the 7. So let's just do it mentally. 7 plus 1 is 8. 8 plus 3 is 11. 11 plus 4 is 15. Plus 1 is 16. Plus 4. Yep. Loco is right. It is what? It is 24 meters. How about the next one? Sorry. How about this one? So it's 7. I'm going to start on top here. 7 plus 2 is 9. 9 plus 1.5, 10.5. Going on, okay. 10.5, 10.5 plus 3 is 13.5. 13.5 plus 3 is 16.5. 16.5 plus 3 is 19.5. 19.5 plus 2.5 is 20. 22. So what'd you get? Okay, let's see. Everyone, 7 plus 2, 9. 9 plus 1.5, 10.5. 10.5 plus 3, 13.5. 16.5, 19.5. 19.5 and 2.5 is 22. 22 plus 2 is 24. Sorry. Yeah, 24. How many people are getting 24? You got what? How much you get? Everyone, I believe it's 24. Because, okay, everyone, let's do it the other way. Let's do it the other way. 7 plus 2, 9. 9 plus 2.5, 11.5. 11.5 plus 3, 14.5. 17.5. 20.5. 20.5 and 1.5 is 22. 22 plus 2, yes, it is 24. Everyone, this also is 24 meters in distance. Okay, how about this one? Do we have to know all sides, or are all of them given? Given, 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 given. Oh, all right. So, okay. So, Sarah got 27 for this. Let me just check quickly, everyone. 7 plus 2.5. 9.5. 9.5 plus 2. 11.5. 11.5. 12.5. 13.5. 14.5. 20.5. 22. 24. 27. Sarah's right. 27. 27 what? 27 what unit? Yeah, this is apparently a floor plan on paper. That's why it's not in meters, it's in centimeters. Like something you can fit in what? In on your paper right now. Okay? All right. Okay. Measure. All right, people. Whoever is interested in measuring, come on, use your rulers. Go. What's A to B? Come on. That's the last thing for the. Okay. If anyone wants to confirm / correct, who agrees that AB is 4? What is it? Come on. Sure. What do you have? Hold on. Like 9 or 3.9? Oh, okay. Everyone, let's go with 3.9. Go ahead, 3.9. So put it here and put it here as well to make it easier to look at the end. What's B to C? By the way, B to C and D to E are the same. B to C, this one, and this one obviously have to be the same. No questions about it. So give me just one of them. What's B to C? Okay, so Ty is saying B to C is 4.5. Whoa, hold on.
No,
For the
no,
first,
B to C.
yeah, B to C, just B to C. No, I think Jay is talking about A to B, which is what? So, oh, 1.5. Sorry. No, that's a big difference.
It is 1.5.
5? 1.5, everyone, which is the same as D to E. So immediately go ahead and fill this one up. Okay, who's got the bridge right here? Everyone, the bridge, C to D. Come on, C to D, CD. I know mine squishes, so I can't trust it. How much? 2.5? 2.4? Okay, let's go with 2.4 this time. Okay, how about E to F? E to F. Khalil, come on. E to F, that top side on the right. It could be like A to B, I don't know. Is it? Is it? It looks very close to A to F. We want E to F. Okay, go ahead. Okay, let's go with 4.5. 4.5. Okay, what's F to G? This side, everyone. This side, right here. F to G. What are we talking about? What? Hold on. Seems to be the longest one. Actually, no. Oh, wow. Mine really. Look, I thought it was the longest. No, mine squished it really too much. It's actually not. It might even be less than EF. What'd you get for FG? 3. Yeah, F to G. Sure, sure. Let's go with 3.9 then. Everyone, 3.9. Okay. How about G to H? This distance right here.
No, 1.9. 1.9.
2. All right, everyone. So write 2.0. Just write 2.0. Let's keep it nice with all one decimal showing. How about H to I? This little distance here. 1. Okay, so 1.0. Okay, who's got I to J? People agree? Is it 2? 2 point, so 2.0. Again, it's okay. Again, these questions will always be given to you as show your work. So I will just see if it makes sense. How about J to K?
0.5.
Zero. I know it's 0 point something.
It's 0. Yeah.
5? No. K to L. K to L is 5.3. Okay. I think that makes sense. How about L to M? This one. Yeah, it could. I mean,
Yeah,
it,
it is.
it kind of looks like H to I. So I'll go with 1, sure. Good. Almost done. Only 2 more to go. M to N. 1 point what? 5? Okay, I'm going with Sarah. Unless I,
Over 5. What?
like, how much over 5?
Like N, it's N to A?
Sorry, N to M. Sorry, yeah, M to N.
Oh,
That,
no.
okay. How about the longest one, which is A, N back the way to, back up, back to A? Uh, Really?
Yeah.
Yes, it is as close as KL. Thank you. So 5.4? Okay, everyone, 5.4. So what's the final thing? Well, the final thing is the total of the whole thing. All right, let me just zoom out so you can see it, and then I can just, so, sorry. Okay. Oh, I have to. And I would definitely ask you to help just in case I mess up because there are so many sides. I'm going to try to be slow and focused. So 3.9 plus 1.5 plus 2.4 plus 1.5 plus 4.5 plus 3.9 plus 2 plus
I got
1
36.5.
plus 2 plus 0.5. Okay, plus 5.3 plus 1 plus 1.5 plus 5.4. Ready?
Yep, I got 30.
I guess we're right. So the perimeter is 36.4 in what unit? In centimeters, because that's the scale diagram that we just measured. Describe how to calculate the perimeter of figure. Add the sides. Done. Why talk too much? Add the sides. Add all the sides. Don't forget anything.